Hello everyone. Today we're going to talk about electromechanical relays. So first thing up, we need to know about the coil voltage. Is it AC or DC? What's the rating of the contacts? What type of socket are we using? And any other additional features. So right here we've got the MY2N D2. This is Omron brand, 24 volt DC. It's pretty obvious up front what we've got here. So there's your part number. Here's your coil voltage. Right here we've got our contacts displayed. So this is a 2-pole. Then we've got our coil down here. So with our contacts, we have number 8 is our common. Number 12 is our common. Number 8 is normally open. Number 4 is normally closed. Same on the other side. Number 9 is common. Number 5 is normally open. Number 1 is normally closed. 13 is negative. 14 is positive on the coil. We already determined that it's 24 volts DC. So let's see what have we figured out so far. I'll switch back over here. So we know right now the coil voltage is 24 volts DC. Is it AC or DC? Yes, it's DC. Contact ratings, we don't know that yet. Socket type, we don't know, and any other additional features. So let's flip it over, take a peek at it again. Let's see if we can get the light on these contacts a little bit better. You can see right there you got 13, 14, 9 and 12, 5 and 8, 4 and 1. Now if we look at this relay, you can actually see the coil down here. It's blue. The common wire is white, comes up around here. Then we got our contacts. So you can actually see where the contacts come in. This common follows back around, goes out through here, and then of course R normally opens at the top. At the bottom. It's hard to see it. Let's move it a little bit so we can see. There we go. So this is the normally closed set, and this is the normally open. Another way to figure out your additional features is from the interwebs. So we can go right here to the Omron website. And look, we have the MY2N D2 24 volt DC. So here we have our coil rating, 24 volt DC, 36.3 milliamps. That's how much draw you have on the circuit. You have an operating indicator, LED, coil surge killer. So this is an additional feature. This is part of the D2 in the part number up here. So this D2 indicates that you have a diode, and here's a coil surge killer. We've got a double pole, double throw. Contact method is single. Here's our contact material, and then the rated loads for our contacts. Terminal structure is a plug-in terminal. Now if you look around on the website, you can see a few extra things. So we go into a little bit more detail. Now look at this one. This will come back later and be important to us. 662 ohms on the coil resistance. Let's see what else is here. So here's your operating frequency. Contact resistance, 50 megohms max. Operating time, 20 milliseconds. And I was looking for, no, I don't see a failure rate. Here we go, failure rate, 1 mil. No, that's not what I'm looking for. Endurance mechanical, there you go, 100 million operations minimum. Okay, electrical, 500,000 operations. So this will last a long time. You got your terminal arrangement, and we'll zoom in on this a little bit so you can see it a little better. So this is telling us the same thing that the front of the relay tells us, and this is our suppression diode here. So you can see there's positive on terminal 14, negative on terminal 13. It's kind of hard to see in this one. Let's zoom back out a little bit. Look at our characteristic chart. So we got our contact current versus voltage. We have our AC inductive load, DC inductive load, resistive loads. Let's go back to the relay. So I think now would be a good time to, well, let's look back at the PowerPoint and see where we're at. Let's pull that back up. Give me just a second here. I lost my mouse. There it is. Okay. All right, let's switch back over to that. Okay. So next up, we got our components. We talked about the normally open, normally closed, and common, the return spring, the armature, the electromagnetic coil. So we already identified the terminal numbers. We're going to go back. I'm going to take this apart, and then we're going to go over each one of these components where you can see them a little better. Okay, now we're back. I've got the cover off of it. You can see quite a bit more. We can see our return spring over here on this side. That's attached to the little pivot point here with the armature. Let's go ahead and take that off. I'm going to take that off real quick, come right back. So now we've got the return spring off. And now you can take the contact out, or the contacts out. So these are our common contacts here. 2 sets, right? And you can see the pivot point's pretty simple on this relay here. It just sits in these notches there. Let's open it up a little bit more. So it just sits there. So here's your coil. So again, when power is applied, this pulls the contacts down. Now I've got them out. But looks like these contacts are pretty clean. They haven't really been used a whole lot. And you can see right here with these contacts, they just go straight through, just straight through. Common as well as on the little wire. And then you can see the coil wire here where it's actually soldered. And we got our indicator over here on the other side. Okay, so we're back. That was my executive producer. She's about 7 years old. Come down and give me some production notes. But you can see as power is applied, this will close, pull down the armature, and our normally open contacts are now closed. So remember, with the contacts, it's always in the state of powered off. If it says normally open, that means power off. That contact will be open. Normally closed, the contact will be closed with power off. Let's see if we can get the focus to come back. Maybe not. Let's see. Let's play around with it a little bit. It's not too happy. Not too happy with the focus there. Give her a second. Come back in. Seems to be wanting to focus on that light up there. Well, let's just pick the camera up. So right here you can see the little LED, little surface mount LED, and the resistor that's in series with it. And we'll just put that back right here. So I'm going to put this back together now. Okay, so now we're going to check the relay. So we're going to check the contacts with a continuity check, and we'll do a coil resistance check. So anytime that you are working, can't see that meter too well, can we? Let's move this around. Let's move this on this side. There we go. Oh yeah, that's good. Okay, much better. So anyway, anytime you're checking resistance, you need to make sure that you do it without the power on. Your meter actually puts out a small amount of voltage. This could damage the meter, and so don't do that. So anyway, right now I'm in resistance mode. Let's see, let's slide this meter up a little bit more. I've got continuity test under, and so from earlier, pins 13 and 14 were our coil. Now remember, from the data sheet, we were expecting to see about 600 some ohms, and we do. We see 646 ohms. Now remember, this is the common contact, normally closed, normally open. Let's double check that. My bad. This is normally closed, normally open, common. So we'll go to common. I'm trying to get off the coil here. Let's do like that. There we go. And we got a good contact there. Good connection. We'll go here, 0.3. So sometimes with relays, you may have to map out your connections, know where your terminals are, and know what they do. Mapping is something that you end up doing a lot with electrical circuits. But so far this thing looks good. Now with this relay, you can't actually test it or manually turn it on. So I couldn't test the normally open contacts. But from looking at this relay and making a quick judgment of it, looks like it's good. Now another thing to think about with these ice cube relays is I can just pull one out and put another one in. Make sure it's the same rating, but I could swap too if I think I have a problem and troubleshoot very quickly. Also, you have the indicator to let you know at least you're getting power to the coil. Okay, so that's it. That's how you check an electromechanical relay. These are the components, the pins, the data sheets, everything you need to know about this very simple device. Thanks for watching.